way back in first semester, we learned about complex numbers. And complex numbers look like this, a plus bi. And we found that we can take the absolute value of that complex number by doing the square root of a squared plus b squared. That should look really familiar in this chapter since we've been doing a lot of square root of x squared plus y squared. Same exact idea. So we're going to be converting back and forth between polar and rectangular forms of complex numbers. So in a polar form of a complex number, the r is what we call the modulus, and the theta is the argument. A little bit of vocabulary. So, very much like what we did in the last lesson, we find the r value. It's the square root of 9 squared plus 7 squared. So that's the square root of 130. And the square root of 130 is 11.4. In order to find, so this is our modulus. The argument is theta, which will still be found by taking the inverse tangent of here 7 over 9. And when I do that in my calculator in radian mode, I get 0.66. And now I'm ready to rewrite the rewrite the complex number in polar form. And so it will look like this. It will be r, which is 11.4, times the cosine of 0.66 plus I times the sine of 0.66. Part B, same exact idea. Find the r value. It's the square root of -2 squared plus -2 squared, which is the square root of 8, which is 2.83. My theta value is going to be the inverse tangent of -2 over -2, and that is 0.79. But something doesn't quite seem right because that 0.79 is in the first quadrant, whereas -2 minus 2i is in the third quadrant. So that means I need to add pi to 0.79. So in my calculator, I add a pi to it. I get that theta actually is 3.93. So the polar form of this complex number is 2.83 times the cosine of 3.93 plus I times the sine of 3.93. Here we're asked to graph the complex number and then express it in rectangular form. In order to graph it, what I'd like you to realize is that this complex number, rewritten as a polar ordered pair, would be 5, 3 pi over 4. Well, 3 pi over 4 is here, so I know it's going to be somewhere on this positive part of that side of the angle, and it'll be 5 circles out. So 1, 2, 3, 4, 5. Here is my point. And in order to rewrite it in rectangular form, all I'm doing is distributing the 5 and working out the trigonometry. So if I distribute the 5, I have 5 times the cosine of 3 pi over 4 plus 5i times the sine of 3 pi over 4. So let's just simplify that out in our calculator. In my solution key, it has the cosine of 3 pi over 4 left in radical form. And I would hope that you'd realize, oh, well, that's because they used their unit circle instead of using their calculator. So the cosine of 3 pi over 4 is negative radical 2 over 2. So I would have negative 5 radical 2 over 2 plus 5i times the sine of, the sine of 3 pi over 4 is positive radical 2 over 2. And that's it. For part B, this as a polar point would be 4, comma, 5 pi over 3. 5 pi over 3 is here, so I know my point is going to be somewhere on this positive side of that angle. It'll be 4 circles out, so 1, 2, 3, 4. There is my point. And to rewrite this in rectangular form, again, all I have to do is distribute and evaluate. So 4 times the cosine of 5 pi over 3 plus 4i times the sine of 5 pi over 3. So the 5 pi over 3 again, they're using the radical form found on your reference sheet. So the cosine of 5 pi over 3 is 1/2. 4 times 1/2 plus 4i times the sine of 5 pi over 3 is negative radical 3 over 2. And when I simplify this, I've got 2 minus 2i radical 3. Now comes a very ugly formula. Okay, but let's look at the formula and kind of analyze what's happening in the formula. It's taking, in the product formula, the two moduli and multiplying them together. And then it's adding the arguments. That's pretty easy. So it's long and it's drawn out, but it's just a formula. So in part A, I have 3 times 5 times the cosine of pi over 3 plus pi over 4 plus I times the sine of pi over 3 plus pi over 4. 3 times 5 is 15 times the cosine of 7 pi over 12 plus I times the sine of 7 pi over 12. So this is our product. That's the first part of what they're asking us for. It says then express the product in rectangular form. Well, in order to express it in rectangular form, all I've got to do is distribute and evaluate. So I've got 15 times the cosine of 7 pi over 12 plus I times, gotta distribute, 15I times the sine of 7 pi over 12. From here, it's just calculator. 7 times pi divided by 12. Take the cosine of that and multiply it by 15. And that's negative 3.88 plus same 7 times pi divided by 12. This time I'm taking the sine of it and multiplying it times 15. And that's 14.49 I. And that's the second part of the answer. In part B, same idea. I multiply the moduli together. So negative 6 times 2. And then it's the cosine of the sum of the angles. So 3 pi over 4 plus 2 pi over 3 plus I times the sine of that same sum. 3 pi over 4 plus 2 pi over 3. So I have negative 12 times the cosine of 17 pi over 12 plus I times the sine of that same 17 pi over 12. This is the first part of my answer. This is my product. The second part of my answer is asking me to convert this in rectangular form. Remember, in order to do that, you're just distributing and evaluating. That gives me, in my next step, negative 12 times the cosine of 17 pi over 12 minus 12i times the sine of 17 pi over 12. From here, in my calculator, I am taking 17 times pi divided by 12, taking the cosine of that, multiplying it by negative 12, I get 3.11 minus 17 times pi divided by 12, taking the sine of that this time, and that's a negative number, so minus a negative means I'm adding. So times that negative 12 gives me positive 11.59i. And that's the second part of my answer. In order to do number 5, I need to clarify a couple of things. I thought that I had done enough by writing down the formula, which is E equals IZ. I also need to clarify that the voltage is the E value, that the impedance is the Z value, and that the current is I. So the circuit has a voltage of 120 volts, so I'm going to rewrite that 120 as a polar number. So in order to do that, I need to first realize that it's 120 plus 0i. And so the r for that is the square root of 120 squared plus 0 squared, so naturally that's just 120. The theta is the inverse tangent of 0 divided by 120, which is 0. So rewriting this complex number in polar form, I have 120 times the cosine of 0 plus I times the sine of 0. So that's E. My I value is 8 plus 6j. I'm going to rewrite that as A8, plus 6i, and I'm going to rewrite that as a polar complex number. So r equals the square root of 8 squared plus 6 squared, which is 10. My theta is the inverse tangent of 6 over 8. So in my calculator, I take 6 divided by 8 and take the inverse tangent of that, and it is 0.64 approximately. So now my I value as a complex polar number is 10 times the cosine of 0.64 plus I times the sine of 0.64. And so if I'm trying to solve for Z, I would hope that you'd realize that Z will equal E over I. So I'm going to take these values that I've found, 120 times the cosine of 0 plus I times the sine of 0 over the I value that I found, which is 10 times the cosine of 0.64 plus I times the sine of 0.64. And now I'm going to use this formula. So notice what's happening in this formula. The two moduli are getting divided. That's easy enough. And then it's still cosine of something plus I times the sine of something, and what's inside those parentheses, but the difference of the angles in the order in which they're being divided. So this will become 120 divided by 10 is 12 times, use a bracket, the cosine of 0 minus 0.64 plus I times the sine of 0 minus 0.64. When I simplify this, I have 12 times the cosine of negative 0.64 plus I times the sine of negative 0.64. And then finally, in order to, whoops, I need a parentheses here. In order to write this in rectangular form, since that's the form in which our problem was given to us, all I need to do now is distribute and evaluate. So I have 12 times the cosine of negative 0.64 plus 12I times the sine of negative 0.64. So in my calculator, I take the negative 0.64 and the cosine of that times 12 is 9.6. 0.64 negative. Take the sine of that. That's a negative number, so I know it's going to be minus, and then times 12. So I have minus 7.2 I. And this is our impedance of the circuit. So since it was originally given to me in joules, I'm going to change this I to a J.